Alright, so today we are going to continue talking about lesson 2.7, which was our curve fitting with linear models. Linear regression, again, has a couple different names to it, but we're specifically going to talk today about the line of best fit. So the line of best fit is a thing that we're going to use to estimate data, and this is really only we want to use this when we have a strong linear relationship. If we don't have that strong linear relationship, there's no reason to really use this because it's probably not linear anyways. Okay, so for our line of best fit, this is truly exactly what it sounds like. It's the line that best fits the data, or it fits the data the best. And so we're going to say it is a line that is close to the majority of data points. Okay, so in other words, we're trying to get as close to all of our data values as possible. Okay, now we might not hit them all. In fact, we usually don't hit them all, but we're trying to minimize that distance that we're off for each of those points. Okay, and again, this is really, it fits the data the best. Okay, so it fits data the best. And the other important thing, and this is what we're going to use it for a lot, is this can be used to make predictions. Used to make predictions. Okay, so we're using that equation then that we get to use to kind of find what other variables might be based on ones we already know. And we'll get to those predictions a little bit more down here at the end. Okay? The important thing here, though, that's up at the top here yet, is that the equation for the line of best fit is on the same screen as the R value. So if you go back in your notes and look at all of our steps, these steps, the second one here, will get you that line of best fit as well. Okay? So when we need that, we'll get to that screen as well. Okay? But we're going to go ahead and jump right into an example here. So we're going to use the following data to answer these questions. The data represents here gas mileage in randomly selected cars based on an engine's horsepower, or kind of power that it has. So we have horsepower, we have miles per gallon. We're asked here, to make our scatter plot with the horsepower as the independent variable. Now that's important because that is our x variable. So I'm going to put horsepower down here along the bottom. So it's horsepower, which means our mileage is our vertical piece. Sorry, I missed a in there. Mileage. Okay, and now I need to make that scatter plot. And again, earlier we kind of talked about how to make scatter plots on a calculator. But because I'm trying to actually draw this on my paper, I would say it's actually easier, to just do this by hand. So I'm going to go ahead and create my axes here. Now if I look, my smallest horsepower and my largest horsepower are 110 and 255. So I'm trying to go a little bit below that, a little bit above that. So I'm going to go down to 100. And I'm going to go up by 25s. So this would be 125, 150, 175. 200, 225, 250, and I'm going to go a little bit above that. I could put 275 on here at the very end if we wanted to. Okay. Then going up, I'm going, let's see, my smallest value here is 13 for mileage. My biggest one is 35. So I need to get up there. We'll go up by 5s. 15, 20, 25, 30, 35, 40, 45, 50. And that should be more than enough. I'll just label every 10 here so it's not quite so cluttered. Okay, so there are my coordinates. Now I do need to get all my points on here, so I'm going to go ahead and just graph all these points. I'm going to kind of just keep talking through this because as you do this, you really need to be doing this on your page as well. So just get them close. They don't have to be perfect. You can see with my left hand here, I'm actually pointing to the one that I'm doing at the time. That way I don't lose track. If I glance back at the table, I know exactly which one that I'm on. 115, 32, 190. I'm trying to do this quickly. You should be doing yours at this point as well. So that's roughly what our line looks like, or our scatter plot. And if we look here, we can see this has a pretty general trend downward. And so kind of looking at I should have a negative correlation as we start to look at this. And that really is our next step, is to find that correlation coefficient, which is where we want to bring in our calculator. So now I'm ready to go ahead and enter all of this data into my calculator. So let me get to where you can see what I'm doing here. Again, we talked about all these steps and they're on the reverse of this page, but I'm going to go ahead and start by hitting stat here. Then I go enter on edit. I already have some data in here, so I'm going to go up to the top and hit clear. Again, make sure you do not hit delete. Go over, hit clear, go down. Hey, and now I need to enter in all my data values. So I'm going to enter in all my horsepower, which is 175, 255, 140, 165, 115, 120, 190, 180, 110, and 125. Okay, and I should have all my values there. I typically just kind of click up through here and just make sure that everything looks the same. A lot of times if you miss something, there's either an extra number or you're missing a digit, and so you'll see those kind of out of line. Okay, I got to type in my Y's here as well, which are my mileage. So I have, oh, you can even see there I only use 1, 2, 22, 13, 25, 18, 22, 28, 15, 21, 35, and 30. Okay, so that gets us all of our data. Again, I want to go stat and calc. This gets us to our linreg, and I'm using one of the updated calculators so you can see this. I'm going to go all the way down to calculate and hit enter. And now I again should have all four things here. So I have my correlations down here at the bottom. That's our R value. That's what I'm concerned with right now. So R is equal to negative 0.916. Okay, and then this tells us, or asks us, what does that tell you about the data? So this is negative and it's relatively strong. It's pretty close to 1, about a 0.9. So we would say this is a strong negative, second relationship. And that's our typical kind of response for what does that mean. Strong or weak, positive or negative. So this one is strong negative. Okay. The next part here, part C, this is kind of a new part today. Everything we've done up to this point in this example is really still review. But if we look at C, we want to find the equation for the line of best fit, and then we want to interpret the slope and context for that data. So if I go back here, got a little bit off here, I need to get my linreg back. So here are my values again. If I look right up here at the top, this is my equation, y equals ax plus b. But I have values for both a and b. So what I'm going to do is I'm going to take this top thing, and I'm going to plug that in for b, or for a, and I'm going to take the 47.5, all these decibels, and plug them in for b. And the question I always get whenever we're going through this is, can we round this? The answer is yes, but you got to be careful about where you round. I want you to go a minimum of 3 places, if not more. Okay, so what I'm going to do on this one, I'm going to actually go 4 places, just because if I go 3, I have to round this up to a 0, which bumps the next one up to a 5. I'm going to actually go 1 more, and I'm going to use the 9 to bump the 8 up to a 9. So I'm going to have here y is equal to negative 0.1499. So negative 0.1499, and that gets an x with it, plus I have my b here as well, is going to be 47.5088. So since I went 4 in the first one, I'll go 4 in the second one. And again, a minimum of 3. Here I went 4 just so rounding was a little bit easier. Okay, but this is our equation. If I graph this line, I would get a line that goes on this scatter plot up here. That is a good prediction of this line. Okay, so it's going to come through somewhere. If it's crossing at 47, it's actually up here a little bit. It's going to kind of cut through and be a good representation of that line. Okay. From there, we are going to go ahead and interpret the slope. So the slope is the value that goes in front of the x. So that's the negative 0.1499. And because it's negative, we know that that means we're decreasing. Okay? And so what we're going to say, and this is one of those sentences we use and we just kind of switch out what the variables mean, is we're going to say that each increase of 1 horsepower that's our first variable, lowers mileage by 0.1499. Okay? And again, that sentence is something that we're going to use quite often. So for an increase of 1, whatever our units are, or whatever our first variable is, here it's horsepower, is either going to raise or lower our second variable by whatever that slope value is. Okay? So that's a pretty generic statement there. Excuse me, that we're going to use kind of through this whole thing. Okay? Let's go ahead and go on to D and E here. Both of these are making predictions. So like we said at the very top, we're going to use our line of best fit to make predictions. So I'm going to be using this equation here that I found from my calculator, and I'm going to use it to predict what a 200 horsepower engine's mileage would be. Okay? So if I like 210, that was my X value, horsepower. So I'm going to go ahead and plug the 210 in for X, and I want to figure out what Y is. So Y is equal to negative 0.1499 times 210 plus the 47.5088. Okay, again, I'm going to pull my calculator over now. Now I'm just using the regular calculator. I'm going to do negative 0.1499 times the 210. I'm going to do that part first, gives me negative 31.479. Again, not super important, but I need to add the 47.5088 to that, and I end up with 16.0298. Right, and that is miles per gallon. And I do just want to verify, if I go up to the top here, 210, I don't really have any numbers that are close to it, but I have a 190s at 15, I have the 255s at 13, a little bit above that's a little higher. So this one does make sense. Okay, it's going to sit right in here with the rest of these. Okay, so let's go down to the very bottom here, and we have one that's kind of going the other way. I can also ask you to work backwards. So if I give you a mileage, I can ask you to predict the horsepower. So mileage, again, was our Y coordinate, so I'm going to put 20 in for Y. And now, if I copy everything else down, plus 47.5088, I need to get X by itself. To do that, I need to get rid of our Y-intercept here, so I'm going to subtract the 47.5088 minus 47.5088. And when I do that, our right side cancels there, and we're left with negative 27.5088 is equal to negative 1.1499x. Divide by your amount there on both sides, and we get our answer here of x is equal to 183.514. And that is all in horsepower. Right, and again, that 183 for an input of 20 should make sense. If I scan through my mileages here, I have an 18, which is at 165, so relatively close to that. I have a 21 at 180, okay, and they just have to be in the ballpark. They're not going to all be perfect. They might both be higher or lower or anything like that. That's fine. I just want to make sure I'm ballpark pretty close. Okay, so let's go ahead and flip over. We have one more example here. This example is very similar. I'm just using a different set of data. So one of the big things with linear regression is there's a lot of real world scenarios that we can do that actually use this. And so one of those people are what we call anthropologists. These are the people that kind of study antiques. They look at fossils, they look at old civilizations and try and kind of create different things. And one of the things that they study a lot are skeletons and bones that are found. And so usually when we find skeletons or remains like that, we don't have a full body anymore. Everything's decomposed. But what they found is that if they know the length of the femur or your thigh bone, they can predict the height of the person. And so here they've given us a bunch of lengths and heights that they knew all of this. And we're going to use this to then kind of get some predicting pieces that we can use. Okay, but again, to start, I want to create my scatter plot here. For the sake of time, I'm going to let you just do this. So you can go ahead and pause the video. You can go ahead and draw in all that scatter plot. I'll tell you here again, they tell you length is your independent variable. So length will go on the bottom, height goes on the side. Okay, find your high and low values and make a scale that makes sense, and go ahead and just plot those points. I'm going to go ahead and move on to part B. Okay, part B then is to type this all into our calculator. So again, I'm going to get this turned on here. I'm going to stat into edit. So I'm going to enter there. I have my old data in here, so I need to clear that out on both sides. And I'm going to go ahead and enter all these data points. So x's, or the length, are going to go into L1, and our other values, our heights, will go into L2. 35, 38, 30, and 27. And on the other side, I have 160, 143, 187, 142, 161, 164, 140, and 131. Alright, so again, just want to scan through both of these and make sure that they make sense. And they do. Okay, so I'm going to go ahead and stat calc over to LinReg again, all the way down to calculate, and hit enter. At this point, we're going to go ahead and use these values. So I'm going to ask for my correlation coefficient here. R is going to be 0.986 if I round the 5 up, which is pretty good. That's pretty close to 1. So I'm going to say that this is a strong relationship, and it is positive, okay, because that is a positive R value. So this is a strong positive relationship. Okay, part C wants us to find the equation for the line of best fit. Well, I already have that here on my screen. I just got to fill it in. So I'm going to end up with y is equal to, I'm plugging A in first. So this is going to be 2.91. I'm going to go to just 3 places this time. So 2.915. That gets the x, plus our B, which is 54.041, which I'll round to a 2. So this is going to be 54.042. Okay, I'm also asked to interpret that slope and what that means. So our slope was the 2.915, this number here. So I am going to say, and again, this is very similar to the sentence that I said earlier, I'm going to say as femur length increases 1 centimeter, height increases 2.915 centimeters. Okay, so that gives us kind of a general idea then of what that slope means. It means as I'm increasing 1 centimeter in that thigh bone, that person's getting 3 centimeters roughly taller. Okay, so let's go ahead and make some predictions here. So like I said, this has a real world context to it that we typically find a femur. And so both of the predictions that we're going to make are based on a femur length. We want to know the height of the individual. Okay, and we also want to know, is it reasonable? Okay, would it make sense that a person could be that height? Okay, so let's go ahead and work through this. The first one, I have a length of 23, and that femur length is going in for x. So if I go ahead and plug that in, I have 2.915 times 23 plus our 54.042. Okay, again, I pretty much just typed this straight into my calculator, but you could do it in 2 chunks if you want. I had y is equal to 121.087. Okay, and that's in centimeters. If we think about that, 100 centimeters is a meter, which is a little more than a yard, so a little more than 3 feet. So this person is not much more than 3 feet tall. Okay, and their thigh bone is maybe about a foot. Okay, so this seems a little bit off. Okay, it seems like that thigh bone should give somebody that's a little bit taller, but I would say it's still reasonable. So I'm going to say here that it's small but reasonable. That person would be relatively short, and a good portion of their body is that thigh bone. But who knows? That could still make sense. Right? Sometimes people are a little shorter. Right? We also have one going the other way. So we have a femur length of 50. Let's go ahead and plug that in. So y is equal to 2.915 23 plus 54.042. Okay, again, I typed that all in. And for my answer, I got 199.792 centimeters. And this is kind of on the opposite end. This is almost 2 meters long, which is a little over 6 feet, almost 6'6". And so this is definitely a person that's relatively tall. I'm sorry here, I plugged in 50. Fix that. I plugged in 50 there in parentheses. So again, this is a relatively big person. They're pretty tall, but I would say again, it's still reasonable. And we have people that are 6'6", 6'7", which is kind of the range that we're looking at. So reasonable, but a little bit big. Okay? If something was not reasonable, we would get like a negative height or something like that. That just doesn't make sense to the context. Okay, so that is your notes for today. However, I want to quickly show you something. I know not all of you have a graphing calculator at home, so I want to quickly show you here. I'm going to hop over on my computer, and you're going to see here where you can do this on my website. So on my website, if you go to jbrownmath.weebly.com and go up at the top here to Algebra 2, hover over Semester 1, and we are in Chapter 2. You're going to get to a page that looks like this, and on the very bottom here, there is this regression calculator. So I'm going to switch pages here because I already filled in the data from the last one. So when you fill in the data in here, this is from our femur and height example that we were just looking at. It actually creates the scatter plot over here on the side. And again, these numbers are just too small. So if I hit the minus, I'll zoom out, and I can see my data shows up here. You can zoom back in and kind of shift over and make my graph look good. You can also click the little wrench here, and you can change your scales on both your x's and your y's and make that all work. Okay? But again, scatter plots are not what we're focused on. We're focused on that regression. And so if I look over here on the left-hand side, you're going to enter all your data here. If I go back to the other one, you'll see it's blank. You can just enter your data in for x's and y's like L1 and L2. But once you do that, this bottom one actually becomes your equation. And you'll see here it gives you m in b, which is the same m in b that we have in y equals mx plus b. And it also gives you your r values. We're talking about just the r down here on the bottom. Okay? But you'll see this is the exact same numbers that I used when we were working through our problem on the calculator. So you get the same answers. It all works out the same way. I would prefer you use a calculator in class, mostly because that's what you have for an SAT or something like that. But if you're at home and you need help with this, this is one place that you can go. Okay? So take a look at this. Okay? Your homework is listed on the backboard, so you can go ahead and take a look at that. That will all be due tomorrow. There's not a ton of problems there, but again, a lot of them are entering data and kind of working to get this equation. Okay? All right, I hope that helps you out.